Alright, welcome back. We are going to take the triangle plate that we just made in the last video and do some analysis on it. So I'm going to switch over to ANSYS here. So we should be able to see our projects page. We still have our geometry on there. I'll get rid of myself in a minute here, but to add our static analysis to that, we're going to select the static structural, drag that in. We can either drop it here, or if I automatically want to share that geometry, I can drop it here. So I already created this geometry link. If I did that by mistake, I can click on the link itself and just delete it. If I did that by mistake, I can share that link again by just dragging, and it gives you a little warning like, hey, you're going to share this information. Do you want to? Yes. And I'll get rid of myself while we're waiting there. And one thing to note, since I'm doing this in 2D, I want to select the geometry here on the project schematic page and change that mode over to 2D. If I import the geometry and everything, it will be a problem when I get into that. And I can only change it before I do that. So if I mess it up, I'd have to start over and link that geometry again. So I'm going to open up Workbench. This would be like ANSYS Mechanical, and it is saying it's starting mechanical. I'm guessing it's going to open on my other screen, but I'll pull it over in a second. Still loading. Alright, there it is. And let's see, can I get it? Still loading some kind of add-ins or something. There we go. Let me pull that over to the correct screen. There we are. So in here we have our project tree. We have some details of whatever we selected. There's some notes and things you can see down below here. And you can see we have our geometry coming in. That looks like a nice 2D geometry. I can look in here that I'm pulling in that geometry from A2. That was back on our project schematic. Here is A2. So that's what that is referring to. I also select what kind of material I'm applying. So this is structural steel. This comes from the engineering data on that project page as well. There's some other materials out there if I need to, but I can also switch between windows here and there, so I can look at the engineering data material or the geometry. Alright, so the meshing, we're just going to do the regular meshing. Sorry, I jumped ahead. I do want to tell you how thick this is. So I said in the last video I wasn't going to say how thick it was when I made it in the geometry. Here I'm going to say in mechanical that I want it to be 10 millimeters thick. And now I will do the mesh. I'll just generate the mesh. Should just take a few seconds. It's a pretty simple model. Yours might look slightly different than this. But now it's showing it in that 3D view, but it's really only one set of nodes, like a 2D set of nodes. One good thing to check is your number of nodes and elements. So in this case I have 495 nodes. They are shared among 143 different elements. Not the prettiest mesh in the world, but we'll take it as a first step here. Moving into our analysis settings, I'm going to turn on this weak springs option. This just helps keep a model from going flying off the page essentially. And as we've talked about in class, for FEA we create our geometry, we discretize that, so we break it into nodes and elements. We make those element stiffness matrices. So depending on what kinds of nodes and elements we selected, we create those nodes, we create those elements. Those relationships are already built in. We already specified a material property, so that stiffness matrix is there, the global stiffness matrix is there. Now we just have to apply our loads and boundary conditions. So that happens in the static structural. There's a few ways I can do that. One is I can right click, say insert, and I'm going to apply this as a pressure. So I'm going to apply it to this face. If I hold control, I can select that face, and then hold control there, apply that. So there's 3 edges, and I'm going to pull on this 50 megapascals. And that should do what I want. So that's one way I can do it. Another way I can do it is like, I'm going to go back in here. So that's my loads. I didn't apply any other boundary conditions, right? We're pulling on all of these equally. None of these other places are fixed. If for some reason I did have a fixed condition, I could like right-click that select the geometry and then apply like a fixed support or a displacement or whatever on that. I'm not doing that this way. So I could have done that as well. Instead of doing the right-click insert, I could just select the edges and then right-click and put in the load on that. So I should be able to solve now. I can also insert some other things. So I might want to look at results like, say, what's the total deformation? I might want to say I want to see in a certain direction, and now I can say what direction I want that to be, what time step I want that to be. We're only looking at one time step in this case, hence the static structural. And maybe I want stress as well, so I can put in stress. I'll just grab equivalent von Mises right now, and I can hit solve. And I can change some of the solver settings here. How many cores do I want to use? If I want to distribute this or not. If I undo that, I can solve that. I could also send that someplace else if I configured it to have like a high computing center or something like that. I'm going to hit solve. It's wandering away. It's telling me, yes, we need those weak springs, otherwise it's going to fly away. And let's see, there we go. So there's our stress results. Here's our directional deformation in the x direction. And it tells us up here what that is. If I want to know at a specific point, I can grab this little probe tool, kind of hover on those. It's going to lock to kind of different nodes on that, so it kind of jumps around. I don't get a continuous piece of that. But you can see it's fairly constant there. And my total deformation, so it'd be in x and y. So that's how far these things have moved each way. And I would have expected that to be the same that way. But I do see that there's some sort of symmetry. Let me click this axis to make that look nice there, right? So if I take a slice of this direction, I basically get the same thing on top as I get down below. So that's the first bit of this tutorial. There are some other steps. So I would say, how far did we get into the tutorial? So we'll just look in here, looking at my book. This got us through 3.1.9. They introduced the simulation of a symmetric model in 3.1.11. So we just mentioned that symmetry. In 3.1.11 we say, okay, we're just going to chop this in half. Maybe we'll add some more nodes because we can do that. We might also look at, say, oh yeah, this is kind of doing the same thing this way as it is that way. We might solve it, see some symmetry another direction as well. So they walk you through adding more nodes, making a better solution, talking about that as they go through. So hopefully that's helpful. If you have questions, we can talk about it in class, or you can catch me other times, and we'll go from there.